Welcome to the walkthrough for the specifications, skeletons, and unit tests for Assignment 4, Part A. The objective of this part of the assignment is to learn how to use the Android Async task framework and Java barrier synchronizers, which are described in the following videos. I recommend you watch these videos to ensure you understand the Android Async task framework and Java barrier synchronizers. Naturally, these topics are covered in class as well. In this part of the assignment, you'll use an instance of the Java Thread Pool Executor class that's created as a dynamically sized pool of cached threads to enhance the multi-threaded implementation of the Palantary Simulator app from Assignment 2A. Assignment 4A focuses on creating a pool of threads and using it in conjunction with the Async task framework to allow beings to concurrently gaze into a fixed number of Palantary. The Palantary Simulator app is packaged as a project in Android Studio version 3.3. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 4A, however, you only need to be aware of the following three directories. The Beings Async Task folder, which contains the skeletons you need to fill in, as we describe shortly. The Unit Tests directory, which contain unit tests that exercise many Palantary Simulator features, and you should use these to help test the functionality you implement for the assignment. And the Android Test directory, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you'll need to use the provided Android Studio project. As always, you can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you've created one, which of course at this point you should. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here tasks in order to create a working solution. As always, don't change the overall structure of the skeleton, just fill in the to-do tasks. You'll need to finish implementing the following to-do tasks for this assignment in the Async task folder. First is the async task manager.java file. You'll need to complete the to-do tasks in the various methods to implement a being manager via a dynamically sized thread pool that uses the Java Thread Pool Executor and the Android Async task framework. You'll also need to implement the being async task.java file, where you'll complete various methods in this class using an instance of the Android Async task class that you've customized to perform background gazing, logging, and barrier synchronization operations. You'll also need to integrate your solution for the concurrent map fair semaphore folder from Assignment 3B into the latest, greatest concurrent map fair semaphore skeleton and use it as the implementation of the Palantary Manager for Assignment 4A. Naturally, you need to make sure you fix your concurrent map fair semaphore to work properly based on the comments I gave you for my review of Assignment 3B. Your app will be considered correct if it passes the unit and instrumentation tests and all the beings successfully complete all their n iterations. A correct simulation, of course, should restrict the number of gazing beings to the number of Palantary, such that if there are 4 Palantary in the simulation, then only 4 beings should ever be gazing on the screen at any given point of time. When the simulation is running, the app view will display visual feedback to show Palantary and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, the app title bar labels will appear green when the simulation completes. However, red title bar labels will be displayed when the simulation completes if the implementation throws an exception or is not implemented correctly. Grad students, or students who are taking this course for grad credit, must perform the following additional tasks. You'll need to enhance the async task manager.java file to use the Java 8 streams and associated features, such as method references or lambda expressions, that we've discussed earlier in this class. Naturally, undergrads are also welcome to implement these methods and features, though it's not required. The skeleton code for this assignment is available in my GitHub account. Once you've set up your GitLab account, which I'm sure you already have at this point, you can pull the skeleton code in your repository, read through it carefully, watch this video completely, and then fill in the to-do markers. The additional work required by grad students is clearly marked in the skeletons. This assignment is designed to deepen your knowledge of writing concurrent Java programs using the Android Async Task Framework and a thread pool executor, which complements the Java executor framework mechanisms we covered in assignment 2A and 3A. You'll also, of course, get a chance to play around with the barrier synchronizers we've covered earlier in the course. We don't make any changes to the Palantir Manager from assignment 3B. Of course, this will be replaced in assignment 4B that'll be coming up shortly. So async being implements the gazing logic of a being by forwarding to an instance of Android async task. The async being is going to extend the being class, which is something that you've been doing so far for the other implementations. We're then going to have something called an async being task instance called masync task. That's going to be used to actually run the being gazing logic in a background thread. We'll take a look at that in a second. Here's the constructor that's provided for you. The interesting method that you'll first have to implement is called execute on executor. And that should give you a hint as to sort of how to use this in conjunction with the async task that you're going to have to implement and initialize to the masync task field. As you can see here, you're past a couple of parameters. You're past a cyclic barrier called the entry barrier, and that's used to ensure that all the threads start running at the same time. And you're also past something called a countdown latch, which is known as an exit barrier, and that's used to ensure that the threads finish at the same time, so everything's properly synchronized using barriers. And then the third parameter that is passed here is the executor to use, and you'll have to pass that appropriately when you do the right calls. So the first thing to do here is you'll create a new async task. We'll take a look at the async task you'll have to create in just a second. And then once you've got the instance of the async task, you'll execute the tasks on the given thread pool, which of course is what's passed in as a parameter. If you watch the video, you'll understand how those things are defined. Let's make this just a little bit bigger. So here is a factory method that creates and returns a new being async task that when run will perform the various gazing operations. You can see here that you're basically passing in the entry and exit barrier. You'll have to replace the null here with the appropriate code. This should be very straightforward. Here's another method that you have to implement. This is going to cancel the execution of a task. And what happens here is you're going to have to forward the call to cancel to the masync task field that you have so that you can tell the async task to shut itself down. And make sure you pass in the Boolean may interrupt if running so that it knows how to handle that properly. Here's a method that's left over from things you've done before. This should be pretty straightforward. It's just copying from the earlier solutions to implement the acquire, Palantir, and gaze method. This just performs a single gazing operation. No real change here from what you've done before. Just make sure you copy it in properly. Here's where things get a bit more interesting. This is an async being task, which is a class that extends async task. And as you can see, we're going to provide some interesting parameters here. We're going to have an integer, which is going to be used to pass the number of gazing iterations to run in the background, in the do in background hook method. And then we also pass a string in, and this is used to indicate the success or the failure of the do in background method. It's going to indicate what happens when do in background finishes. Inside this class, we're going to define a couple of fields, which will hold the cyclic barrier and the countdown latch, which play the role of the entry barrier and exit barrier, respectively. Here's the constructor. You can see it just squirrels those parameters away in the fields. And now we have the various hook methods that are invoked by the async task framework before, during, and after the various stages occur. So there's a on pre-execute method, and that's invoked by the async task framework before the main do in background hook method starts to run. And what I want you to do here is use the local log method, which is defined down here. Just use the log method in order to print a string that indicates this method has been called for this being. So it's just kind of as a debugging aid. The do in background method is really the hook method that's going to be run to do the gazing logic in a background thread. It's of course managed by the async task framework and the thread pool executor that you passed in when you started everything up. And what you'll do here is you'll manipulate one of the barrier synchronizers, essentially the entry barrier, to avoid gazing until everybody's ready to run. And that, of course, is going to be using the magic of cyclic barrier, which we'll talk more about, or you can watch in the videos.
If something goes wrong, we're going to return a failure message indicating what exception occurred. Otherwise, we go ahead and run the gazing simulation for the designated number of times based on what's passed in as the parameter here. And then we're going to return a value saying things succeeded. When things finish successfully, when things finish without having exceptions thrown or without cancellations occurring, the on-post execute method gets called back. And this is the hook method that's invoked by the async task framework after the do in background hook method completes successfully. So if it all goes well, this method gets called back. And of course, going well means really doesn't get canceled. So if everything works to completion, either by getting an exception or by hitting the end return statement, we're going to end up here, and we're going to go ahead and have you print out the message that's passed, which is whatever is returned from do in background, whatever the result string is from the return in background. That's the parameter that gets passed as the on-post execute parameter. So we're going to print that out using the local log method like we showed before, and then you get to inform the async task manager that this async task is done. And for that, you'll get to use the exit barrier. So you have to figure out how to do that. If for some reason the async task framework is canceled, and for example, if you cancel things through the GUI interface, then in that case, the onCanceled method gets called. And what this needs to do is just forward to onPostExecute, indicating what has happened. And that let the onPostExecute method shut things down. So that's basically what you're going to have to do to implement the async being class. There's a bunch of stuff going on here, and you'll be well advised to watch the other videos of how to implement async tasks, and of course come to class and ask questions in order to get this to work properly. Let's now turn our attention to the Async Task Manager, which is a Being Manager implementation that uses the Android Async Task Framework and the Java Executor Service Framework to create a pool of Java threads that run the Being simulations. You'll need to define several fields here. You'll have to define a custom thread pool executor that contains a pool of threads. They're allocated dynamically and cached. We'll talk about how to do that in just a minute. You also have to define several barrier synchronizers. One is a cyclic barrier, which is called an entry barrier, that's used to ensure all the background threads start running at the same time. You'll also have to define an exit barrier, which is a countdown latch that's used to ensure the waiter thread doesn't finish until all the Being async tasks finish. Then you'll have to define an instance of a thread factory that you'll use to determine how the thread pool executor actually creates the threads that you're using. And what you do here is you'll first initialize the MID field with a properly initialized atomic integer, and then you'll use that atomic integer down here when you make a new thread in order to give the thread a unique name. So each thread that's created by new thread will have a unique name that's created in part by atomically incrementing the MID each time new thread is called. Let's take a look down here. You'll have to implement the factory method that returns an async being, where you replace null with the appropriate code. You've done this before. You'll have to implement the run simulation method, which you've also done before, by calling all the various other methods you're implementing below properly in order to create the being async task for each being using the async task framework and the thread pool executor, and then also wait for the beings to finish gazing and then shutting everything down cleanly. Here's the begin being async tasks gazing method. This is used to create and execute the being async tasks that represent all the beings in this simulation. You'll have to do a bunch of things here. First of all, you'll have to initialize the entry barrier and figure out what the proper count should be. That takes a little thinking to do it properly. You'll also have to create an exit barrier, also thinking carefully about what the right count is. I'll give you a hint. The counts are not the same for these two initializations, so you'll have to think about how they work and what their purpose is. Then down here, you have to create a thread pool executor that contains a pool of no more than being count threads that are allocated dynamically. What that means is you start out with nothing, and then you'll increment every time up to being count number of threads. And then you have to make sure that these threads are only cached for up to 60 seconds. So if they're not used for more than 60 seconds, they get automatically reclaimed by the underlying thread pool executor framework. You should pass in an instance of synchronous queue as the work queue parameter to the constructor of thread pool executor. And then finally, you'll pass in mThreadFactory as the final parameter to the constructor of thread pool executor. And of course, that mThreadFactory is the one that you initialized up here when you implemented the new thread method. It's a factory method that creates a new thread. So after you've done all that initialization work, then you'll need to go ahead and execute all the being async tasks on this thread pool executor, passing in the entry and exit barriers. So for that, you'll need to go back and look carefully at the being async task class to see how that gets done. And for this part of the program, the grad students need to use Java 8 features such as method references and lambdas and or streams, whereas the undergrad students can optionally use these features or just rely on Java 7 features like for each loops. Down here, we have the wait for being async tasks to finish gazing method, which is a bit of a mouthful. And what this does, it's actually pretty straightforward. In this method, you're going to allow all the being tasks to start gazing by using the entry barrier, and then wait for all the being async tasks to stop gazing using the exit barrier. This code is actually quite simple, but figuring out how to use it takes a little bit of thought. So you have to figure out how to fill that in. And then if something goes wrong, if an exception occurs, you need to shut the simulation down right here and now. And that, of course, is by calling this shutdown now method. And in this method, you have to do a couple of things. One thing you have to do first is go through all the outstanding being async tasks and get them to be shut down. So you have to figure out how to do all that in the appropriate way. And in this case, you'll need to be using Java 8 features if you're a grad student, whereas the undergrad students can optionally use the Java 8 features. You don't need to. And then the last thing you'll do here is shut the executor down now.
Now that we've talked about the specification and walked through the skeletons in some detail, let's go ahead and run the unit tests. As you can see, we go ahead and click the run method here. That goes ahead and starts to run the tests. Of course, first we'll go ahead and compile everything, which I've already done. So this goes ahead and runs the test. You can see that it first runs the test that we've got for assignment 4A, which are the various tests that are exercising some of the different features. We'll come back and look at those in a second as soon as this finishes running. And then also, we're going to be running the various unit tests for assignment 3B, which was the fair semaphore test. So make sure that your tests work, make sure these tests work properly for your assignment 3B solution. This will give you another chance to run them. Going back up here, you can see we run a bunch of tests for the async task manager test. We also run a bunch of tests for the async being test. And note that one thing we're not able to do here is run the stress tests for this particular assignment, and that's because the assignment uses Android features which are not testable using JUnit. So we wrote a bunch of JUnit tests to test the various capabilities, and then we go ahead and run, if you'd like to test your program, you can go ahead and run the Android tests up here. I'm not going to go ahead and run them because they do the same thing that they always do. When you go ahead and run the instrumentation test, these basically go ahead and bring up the Android emulator and run the test there and rotate the screen and try a bunch of different things. And it's kind of a torture test for actually running your app in an automated way. So if everything goes well, as they did here, you can see that all these tests will turn green. I think that there's close to 80 different tests, so this will test a lot of your code. If you're not passing these tests, then make sure you come to office hours or stop by and ask questions in class, because it's very important in order to get a good grade that you pass all of the various tests that we're looking at here.